All right, I want to elaborate on this a little bit farther, again, because to me it's extremely important. Now, with all due respect to Darwin, he was using 1859 science, and you have to judge him based on the scientific knowledge he had available to him in his day. Evolution was considered, it was considered a proven fact up until about 1960, and we were told we had to believe it. It was proven, it was known, it was fact, and there was nothing we could do about it except to accept it as a final proven fact. Whoops, I think I cut this off without meaning to. I hope I can get it back on. All right, anyway. He believed that your one-celled animals and plants were simple. He clicked on a simple life. And up until the 1930s, the word simple was used to describe one cell. One-celled animals, one-celled plants. Today, the word simple is hardly used because we now know that bacteria are extremely, extremely complex beyond description. And not only are they mechanisms complex, but the processes by which they have to live, in other words, by which they grow and reproduce, is complex in the extreme. And something else we know is that these processes have to be going on all the time, or basically they die and start to decompose. Now what I'm getting at is that the first cell that was formed had to be formed all at once. Now it's not like when I was at Lockheed we made an airplane. And over here in this department, one person be working on the right wing, over here another group working on the left wing, and over here another person working on the tail. And they would work till, quitting time, then they'd clock out and go home. Come back the next day, work some more. If the airplane had been a living organism, they had to put together the whole thing in a millisecond and get all the processes going within 1 millisecond, or the thing would have decomposed. Do I make a point? Maybe I don't make a point, but yeah, I'm trying to. Now, no, folks, I'm not teaching theology. What I'm trying to teach you is fundamental, basic, hardcore science. The whole thing has to come together in an instant, and I don't know how fast an instant is, and the processes must start as soon as the whole machine comes together, or the thing will rapidly decompose.
Is that part of quantum physics?
That's not part of quantum, that's what we're going to get to, that's something else. That's part, but anyway, that's basically part of what you don't hear in many of your biology classes. Now, I guess I'm not going to get this thing started up again. I regret that. All right, it's going to try. It has to cool down. All right. There are so many angles to this. And it's really hard to know which one, but anyway, I want to give you a little lesson on the DNA. Oh yeah, Charles Darwin, with all respect, did not know anything about DNA and its role in heredity. And again, that's because the science of his day had not progressed that far. He looked at a human cell, and he looked at a rabbit cell using an 1859 microscope. Again, with all due respect, and guess what? The human cell looked to him like the rabbit cell. But the fact is, they're really as different as the human is from the rabbit. Because the human cell, from the time it's first formed, has all the characteristics that any human is going to have. And the rabbit cell, from the time it's first formed, from the time the parents come together, has all the characteristics that the rabbit is going to have. And guess what? That thing seems to have failed. No, okay, it's back. Except it won't leave this and go to this. All right, anyway. Now, what we now know, okay. About the time Darwin published his work, a man named Gregor Mendel did some work on peas. Now, I'm going to pretend that this is a simplified DNA, and again, to be DNA, it's got to have an organization about it and make some sense. So you can go here, and some peas become tall and some short. The blank peas were, some are green and some are yellow. Some were smooth. So now, this is the type of biology I believe you're taught in your biology classes. You've probably seen this reference to peas. That's why I use it. Now, again, so you can have the tall peas were green and smooth, or the tall peas were yellow and smooth, the short peas were green and wrinkled. You know, you can get any combination you have. You have to get the combinations, though, that are in the gene pool. If you only have tall peas in the gene pool, when you eliminate all the short peas, you'll never get short peas from tall ones. That's going to become very important in what I'm about to say later. Now, what about the instance of a mutation? I want to give you, folks, here's an instance of a mutation. Do you see one thing there that looks mutated to you? Letter P, yeah, and it's still functional. It's still readable. That's a mutation. This specimen can still breed its own species. But now, supposing you get something that's mutated so bad, the tall E's were green and smooth, the line comes to an end here. Unless this would happen to meet a member of the opposite sex that convenient had the same mutation that the other one had. And folks, that almost can't happen. In other words, you want to get a long-necked dog. If one dog is born with a really long neck, unless it meets a member of the same species but opposite sex that has the same long neck, the line will come to an end right here. Do you begin to see that this almost renders Darwin's theory virtually impossible? The type of mutations we would need to see have never been observed. Now, here's what has never been observed that Darwin did not know about. For that you have genes switching chromosomes. The tall, again, I switched letters here. I switched this for this. Again, what you have in real life is different species have the same genetic information on a different chromosome. Genes do not switch chromosomes in reality. So the switching of genes from one chromosome has never been observed. New genetic information. Here's the new genetic, them. In other words, them short peas. That's just a, but again, this specimen here could never breed with the other members of the species up there unless it met a member of the opposite sex that had the same genetic information. Again, hopefully I'm making a point. The addition of new genetic information has never been observed. Oh yeah, they just were looking one time at the DNA of slime mold. And they always assumed these slime mold were because they look kind of alike, but then they observed that one slime mold had 19 pairs of chromosomes, another one had 13. How do you go from 19 to 13 pairs of chromosomes? Folk, as far as we know, you don't, or you can't. Changing chromosome, now, something I had said earlier, if you had a gene pool of dogs living on an island, and none of these dogs had a gene for whiteness, they would never mutate into a white dog. You can only get the genes that are in the gene pool, which practically, again, renders Darwin impossible. Now, I want to demonstrate that. I mean, here, I brought in, now, if you're given the information that this is a deck of bridge cards, I'm not going to ask how many know how to play bridge. But this is a deck of bridge cards. Now I'm going to pull out I don't know what card I'm pulling out. Hey, Ace of Hearts. Now this is generally considered a really good card. Ace of Hearts, one of the best cards you can pull. There are rules for which it's not just the card. The card is a member of this deck and has rules by which it can be played. Now what if I were to actually pull out a 1954 Mickey Mantle baseball card from this deck? Then if I would, then evolution would have occurred. Why can't I pull out a Mickey Mantle baseball card from the deck? It's not in the deck. It's not there. The same way with genes. You can't get genetic information that is not in the pool. Now, I've been asked